Hey everyone, in this lesson we are going to solve problem 11 from the collection of problems on higher order functions. This problem 11 says, define and implement a function with the name of COUNTIF that, given a predicate on integers and a list of integers, it returns the number of elements in the list that satisfy the predicate. For instance, here we apply the function COUNTIF with the predicate greater than 5 to the list of all the elements from 1 to 10. How many elements in this list satisfy this condition? Well, a total of 5 elements. It is very trivial to know that these elements are the elements 6, 7, 8, 9, and 10. All of them are greater than 5. Another example of this function could be COUNTIF even to this list. So we need to count how many of these elements are even. That is, they satisfy this predicate. So the output is 2, because only 4 and 6 satisfy this condition. So let us start the resolution of this problem. The first step is to open the terminal and the console in our operating system. And this is the same action whether we are in Mac, Linux, or Windows. For this problem, we are working on a Windows operating system. So, once we are in the console, we just go to the directory where we will save the Haskell solution code file. So we just go to Documents. We have created a folder with the name of Haskell inside Documents. And inside this folder, we will save the Haskell file. So we just create a new Kate file. We're using the Kate editor. You can use any editor that you are used to. We go to File, Save, and then we just save this file in this folder Haskell. Let us just name this file to be COUNTIF. Okay, for instance, what is very important is that you use this extension .hs. With this, we indicate that this is going to be a Haskell file. We click Save. So we have now this file inside this directory. In Windows, we can check this with the dir command. If we just write dir and we press enter, we see that we have here the file countif.hs. Now this name of the file is arbitrary. You can set your file name to the name you want. What is important and mandatory is that your file name needs to end with the extension hs. So this indicates that it is indeed a Haskell programming language file. Alright, let us now begin with the resolution and implementation of this function COUNTIF. When defining a new function in Haskell, the first step is that we need to give its type header. This type header declaration is already given in the problem statement, as we can see. The name of the function is COUNTIF. The input is a predicate, which is basically a function that, given an integer number, it returns a boolean. The second argument is a list of integers, and finally, the output is an integer. Now, why is this function a higher order function? Well, it is a higher order function because it receives, as arguments, other functions. In this case, we have only one function argument, which is this predicate. So, since we have an argument that is a function, this is a higher order function. So, let us define this type header in the Haskell file. So, COUNTIF is a function that, given a predicate, that is, a function that given an integer, it returns a boolean, and given a list of integers as a second argument, it returns an integer value indicating how many elements inside this list satisfy this condition. Now, to solve this problem, we need to understand and know a predefined Haskell function with the name of filter. Filter is a function in Haskell, in this case a predefined higher order function, that given a condition and given a list, it returns another list with all the elements in the input list that satisfy the condition given. Now, why is this function important to solve this problem? Well, imagine that we want to apply our function countif with the predicate greater than 5 to the list of elements from 1 to 10. So here we want to count, indeed, how many elements inside this list satisfy this condition. So here, what if we apply the filter function? Well, this filter function basically returns the list 6, 7, 8, 9, and 10, which are basically the elements inside this list that satisfy this condition. Do we want the list? No, we do not. This function countif does not return the list. This function returns an integer. And what is this integer? Well, the integer is basically how many elements satisfy this condition. So notice that this is basically how many elements we have in the output of the filter function. That is the size of the output list of the filter function. Right, so this is essential. So with this said, let us now comment this, and let us begin the definition of this function. We can simply define this function as given a predicate P, imagine, and a list X, we will return the length of the filter with the predicate P to the list X. So remember, this returns a list, and the length of a given list returns an integer value, indicating the size of this list. Right, if we have something like this, length 293451, this returns 6, because we have a total of 6 elements inside this list. It is basically the length function that we have already learned previously. Now, what is important to add here, and not to forget, is that you need to write the dollar symbol. Now, remember, this dollar symbol tells Haskell that he first needs to compute the list. That is, we first generate this list, and then, once this list has been generated, we compute the length of this list. Why is it not correct if we erase this dollar? Well, if we do not include the dollar, then Haskell will try to calculate the length of a list that is not built yet. This will produce an error. So you have two options. Either you write the dollar. This means with the dollar that the right side of the expression is done first, then the left side, so that we first generate the list and then we compute its length. Or you can also, instead of the dollar, write parentheses, like this. So we first compute this and then we compute the length. Okay, we will use here the dollar notation, which is a more professional and elegant way of representing this idea. Alright, so with this said, we finished the solution of this problem. Let us verify that this is working correctly. We open the terminal, and where we have this file saved, we just open the interpreter. Remember that you can open the Haskell interpreter with GHCI. We just press enter. The interpreter has been opened. And let's check that this function works. But first we need to load this file into the interpreter. To do this, we just write column load, and then the name of the file, which is countif.hs. If you had named this file another name, then you just write the name of your file. We now press enter, and we see that the file has been compiled, the model has been loaded correctly, and no errors have been notified. If any errors had taken place, then the Haskell interpreter will have notified us. So once we have loaded this file, then Haskell can recognize this function or any other function that we have defined inside this file. So let us verify that this is working properly, first of all with the examples that the statement provides. So first, let us check that if we apply countif with the predicate greater than 5 to the list of elements from 1 to 10, we have the result 5. So we apply the function countif with the predicate greater than 5 with the elements from 1 to 10. We have here this list of integers from 1 to 10. So this shall return 5. We press enter and we see that this is right. Let us now check the other example. We need to count how many elements inside this list are even. So this shall return 2, since we have a total of 2 elements that satisfy this condition, the element 4 and the element 6. So we apply the function countif with the predicate even in the list 3, 4, 6, 1. We press enter, and here we see that the result is precisely 2, as expected. And you can apply and verify this function countif to any other predicate and list of integers. For instance, with the predicate greater than 8 to the list, for instance, 91, 2, 6, 12, 7, 15, and 2. So, if we apply this, we can see that we have a total of 3 elements that are greater than 8. And this is correct. We have the 91, 12, and 15, a total of 3 elements. So as we see, this function is working right. We remind the student that he can download all the solution code in the downloadable documents of this lesson, as well as the slides used in this lesson.